Today we're going to talk about interest, two types of interest, simple interest and compound interest. And these are financial calculations that you're going to be doing when you are either trying to save money and you have it put in a bank account, or you're trying to pay money back. Maybe you have a student loan or a loan for your car, or a loan for your house, or something like that. So we'll start basically with simple interest. It's the amount of money that we get paid for lending or investing money, or that we pay for borrowing money. When we deposit money in a savings institution, the institution pays us interest for its use. When we borrow money, interest is the price we pay for the privilege of using the money until we repay it. Okay, the amount of money you deposit or borrow is called your principal. If you deposit $2,000 into a savings account, then $2,000 is the principal. The amount of interest depends on the principal. The interest rate, which is given as a percent and varies from bank to bank, and the length of time for which the money is deposited. In this section, the rate is assumed to be annual, which means per year. So we're going to have a simple interest rate, and it involves interest calculated only on the principal. And here's our formula for simple interest rate. Interest is equal to principal times rate times time. Okay, so I equals PRT. The rate R is expressed as a decimal when calculating simple interest, unless we're going to come over here and use our Google spreadsheet, and we can actually use the percent sign so that our spreadsheet will know that it's going to be a decimal, or you can write it as a decimal. So our formula has principal and rate and time, and they all have to be multiplied together. So it makes sense to, excuse me, oops, that was a mistake. Makes sense to come over in our Google spreadsheet and put the things that we're going to need to enter in. So principal, a rate, and time. Now time is in years, so if it's a portion of a year, we have to divide it by 12. For example, if it's only 3 months, time then would be 3/12, or which reduces to 1/4, 0.25 of a year. But we'll look at that in a minute. A quarter of a year would be 3 months. Okay, and then the interest formula is what we're going to be looking for. Okay, so let's go ahead and look at an example. It says the principal P is borrowed at simple interest rate R for a period of time T. Find the simple interest owed for the money, assume a 360 days. Okay, all right, so we've got $580, 2% interest, 2 years. So this is just as easy as it looks. Put your 580 in for P, because that's your principal. Your rate is 2%, so you can either type it as a decimal, which would be 0.02, or you can let the Google spreadsheet understand that it's a percent. I like to do it that way. And the time T is 2 years. All right, now how do we calculate the interest? Well, we simply, according to the formula, just multiply P times R times T. So I'm going to go here and I'm going to do the equal sign, and then I'm just going to do B1 times B2 times B3. And then I hit enter. And I find that the interest is $23.20. Okay, now let's do another problem. It says the principal P is borrowed at a simple interest rate T. Now we have our time is 18 months. So what are we going to do with that? Well, our P now is $9,000, so we'll put 9,000 in. Our interest rate is still 2%, so I'm going to leave the rate as 2%. Now for the time, you have to think a little bit. 18 months needs to be converted to years. So if you're having a good day, you realize that that's 18/12. So I would say equals 18 divided by 12, because there's 12 months in a year. So that would then convert it to a number of years. When I hit enter, it gives me 1.5. Now, you may have just realized 18 months is a year and 6 months, which is 1.5 years. So either way to do that is fine. Now, see, I automatically had already told it to multiply these columns together, so I got the $270 really quick. So that was kind of fun. All right, now there's a new concept called future value. When a loan is repaid, the interest is added to the original principal to find the total amount due. So this was an example that I took from the book, but if you have, or we could look at this one, if you borrow $9,000 and you pay $270 in interest, then what we would call the future value of that loan is the principal plus the interest. So it would be $9,270. So we have a formula to calculate the future value when you have simple interest. And so here's a new formula. Notice you're still, they call A the future value. So the future value A of P, which is your principal, dollars, at an interest rate R as a decimal for T years is given by this formula. So if we want to create a formula that then does that for us, what we can do is we can say A, I'll go ahead and call it A, and then I'm going to do a comma, and then I'll say future value. So we kind of are remembering. And I think just to be consistent up here, I'm going to do in the front, I'm going to call that the P, just so we remember what these different, and then of course I'll call this one R, just to kind of keep you, and then T, and the interest is actually often referred to as I. So I'll come up here and put an I, just for making it easier. Okay, so our formula for future value is we're going to take the principal and we're going to multiply it times 1 plus R times T. So we can actually go right ahead and input this formula into our spreadsheet. So I do equals the principal, which is what I put in B1. So what's in B1? Or yeah. So I'm going to do principal, and then I'm going to do the times, and then I'm going to do the parenthesis, and then I'll do 1 plus, then R, which is the rate, so that's in B2, so I'm going to do B2, and then times T, which is B3, and then I close my parenthesis, and I hit enter. So it already calculated what we talked about a second ago, which is that would be $9,270. So now we can work a problem. It says the principal P is borrowed a simple interest rate, and they want to find the loan's future value. So we've got $1,000, 6%, 5 years. So we just come in here now that we have our little formula working, our little program. Oops. Okay, so 1,000 is our P. Our rate is 6%. Our time is 5 years. And so our future value is $1,300. So you can see that's kind of just fun little calculation that you can do. So now this one is the same thing. We want to find the future value, find the loan's future value. But now we have 6 months, so that's when we have to do that 6/12 in for the time. But everything else we can just input as we see it. So we'll put 3,000 in. We'll do 3%. The time is 6 months, so you have to do 6 divided by 12. And then, oops, notice I did that, and the computer, because I didn't do an equal sign, it thought that that was a date, like June 12th, 2013. So I need to fix that. It was kind of, didn't know what I meant. I want equals 6 divided by 12. Now, of course, if you're having a good day and you just want to put in 0.5, because you know 6/12 is half a year, that's fine too. Okay, and so those numbers look better. $45 in interest, $3,045 is the future value. Okay. Now, this next question is a little bit different. It says the principal, let me make it bigger so you can see it. It says the principal P is borrowed and a loan's future value A at time T is given. Determine the loan's simple interest rate R to the nearest 1/10%. Okay, so now they give us P, A, and T, and we have to figure out what R is. All right, so I'm going to go through a little bit of algebra with you. This was our formula, A equals P times 1 plus R times T. So you may remember in a previous math class that we used the distributive property and distribute the P through. Now, we're trying to find the interest rate R, so we need to isolate this R right here. So the first thing you do is move over the P on the other side by subtracting it. But if you want to use fancy math terms, that's actually called the addition property. You're just adding negative P to both sides. Now, you're still trying to isolate R. You see that R is being multiplied by P and T, so you want to divide by the product of P and T. So you get this formula A minus P divided by P times T is equal to R. So, and this is actually called the multiplication property. I know you're saying, but you divided. Well, in math, we say we multiply by 1 divided by PT, or 1 over PT, that fraction. But anyway, that part's not really that important. What's important is now I have a new formula that I'm going to use in my Google spreadsheet that will help me find interest rates when I know P, I know A, and I want to find T. All right, so I'm going to go back to my Google spreadsheet and oops, hold on. Let me see what I can do here. Okay. So I'm going to come over here. I think I'm going to copy these little things. So I'll do copy, and then I'll just come over and see, and then I'm going to paste them. Okay. Now I have principal, I have A, and I'm looking for T. So, or no, I have T, I'm looking for R. So, I don't know. I think when I'm looking for R, I think I might need to put this as the last one. So I'm going to copy this and put it down here. So I'm just going to paste it, and I'm going to delete it from here. So, okay, so your principal is the $2,000 for this problem. And the amount that you end up with is $2,600, $2,600. And the time is 4 years. Okay, now we want to know the interest rate, and we have a formula that we just found. You do A minus P in parentheses, you divide that by P times T, also in parentheses. So I'm doing this yellow formula that's right here. So I'll come in here and I'll do the equal sign. Okay, where is A? A is right here, but I have to do the parenthesis first. So I'm going to do parenthesis A minus P, and then I close parenthesis, and then I'm going to divide by parenthesis P, which is in D1. It's kind of ornery. This time, if you've already grabbed D1, it doesn't like to grab D1 again. So you have to do PT. So I'm going to grab T and then go back and grab a D. This is kind of, you know, this Google spreadsheet's free, so it's not the best. But anyway, so I'm going to do TP instead of PT. It doesn't matter. That's the commutative property of multiplication. You can do this. So I'm going to grab the time, and then I'll do the multiplication sign, and it'll let me grab D1 now. I don't know why it doesn't like to grab something twice. Okay, and now I can just hit enter, and it actually calculates the interest rate. Now, it gave me the interest rate as a decimal. If I want that as a percent, I can come up here and do this button, which will format it as a percent. And that's fun. Or you can just do it in your brain. You know, you can format it as a percent. So I think we get to practice that with another problem. It says the principal P is borrowed and the loan's future value. Yeah, and so now we have the same situation. We've got P is $3,400, A is $3,459.50, T is 3 months. So you can handle this because you're snazzy and fast. All right, so $3,400 is what we're going to put in for our P. Now our time, you know, this is 3 months. So you know that's 3/12 of a year. So you do the equal sign, you do 3 divided by 12. And hit enter. The future value they give us as $3,459.50. And then you hit enter, and look at that. It does the interest rate for you, it calculates it for you at 7%. So that's really just cool. Okay, it's fun to make these little programs. Well, here's a chance to make another program. It says, determine the present value P, meaning you must invest to have the future value A at a simple interest rate R. Okay, so now we want to figure out what we need to invest, how much P we need to start with in order to end up with a particular amount at a certain interest rate. So this is actually a little bit easier. Here's our original formula. P is being multiplied by 1 plus R times T. So in order to isolate P, you just divide by 1 plus RT, and that'll equal P. So if we're looking for the principal or the future value, the principal, and we know the future value A and the rate and the time. How do we work that problem? Okay, so I can just come in here. This is the third formula. And I'll go ahead and I'll grab, let's see, we know A, R, and T. So I'm going to grab, I'm going to do this, copy. I'm just going to pop it right here and paste it. The time, copy, and I'm going to paste the future value we're given and the rate we're given. So I'm just copying this, so I don't have to type it again, just being snazzy. Paste, and then we want to end up with, we want to figure out what P is. So I can copy this. I'll put that at the bottom because that's what we're kind of solving for. Paste. All right, so I'm using a little formula. The time that they gave us is 5 years, so I'll put the 5 in. The future value of A, sorry, is 6,500, so I'll put that in here, 6,500. The rate that they told us is 7.5%, so I'll put that in, 7.5%. And now I'm ready to write my little formula, and then every time I'll be able to use this cute little program that I wrote. Okay, so I do the equal sign. According to the formula, you do, it's what's in yellow over here, A divided by 1 plus R times T, that calculation. So I'm going to do A, which is D9 in this case, divided by, parenthesis, 1 plus the R, which is D10, times, so I do the time symbol, and then T, which is the D8. And then I close the parenthesis, and then I hit enter. And it calculates it for me. It makes sense to round this only to 2 decimal places, so I can come up to format, and I can select number, and then 2 decimal places, because it's money, it makes sense. You can even pick currency if you want it to do the little $ for you. Okay, let's look at another problem and see if we get to use one of our 3 formulas now. It says determine the present value you must invest to have a future value A at a simple rent. Okay, good. So this is the same type of question using our new formula. So this is our present value formula. And so we have a time of 6 months. So we're going to do equals 6 divided by 12. Our future value is the A, which is $8,000. The interest rate that they give here is 14%. So I'll do 14 and then the percent symbol and hit enter. And there's my answer, $7,476.64. That's how much money I have to invest in order to end up with $8,000 at 14% interest in 6 months. Now, I'll warn you, finding 14% interest is really hard to do these days. That's a very good return. Okay. In order to start a small business, a student takes out a simple interest loan for $5,000 for 9 months at a rate of 9.5%. How much interest must the student pay? Find the future value of the loan. Okay, well, so what's looking like here is that we're going to have to figure out which of our 3 little programs can we use here. It looks like the first one, how much interest must the student pay? We calculated interest with this first formula. So let's see, their principal, they took out $5,000 for 9 months at a rate of 9.5%. So the principal is 5,000. I'll come up and I have 3 separate formulas here. I hope you see. I could be snazzy and make these different colors. Maybe this might be a bad idea. Let's see. I'm holding the shift down and kind of highlighting with my arrow. And let me see if it'll let me make this a certain color. Sometimes they do. I don't. Maybe under edit. Oh, I don't know. That was probably, oh wait, maybe, hold on. I'm wasting time here. Well, I think maybe this one is the filling it with colors. Yeah, okay. So I could come in here if I want to be snazzy. And this is the formula that the one that I'm going to use. I'll just do maybe a pink. Okay, so this is the one that I'm going to use. Maybe I wanted it to be, like if you want to make it have borders, you can do this button. It's kind of fun. You could do all borders. That's kind of cool looking, I guess. I don't know. So this is the program that I'm going to be using. So principal is $5,000. The interest rate is 9.5%. I'm just typing that in. Now the time, what was the time on this problem? 9 months. So what do? I do equals, and then, oops, I'm in the wrong thing. Over here, I do equals, and then 9 divided by 12, and hit enter. And then my calculation, the interest that I pay is this first one, $356.25. And then I actually answered B right away. The future value of the loan is $5,356.25. So that's kind of fun. All right, let's look at another sort of word problem. It says you borrow $4,000 from a friend and promise to pay back $5,600 in 2 years. What's the simple interest rate to the nearest tenth of a percent you'll pay? Well, that's this one over here. This formula is the one that where it calculated the rate for us. Okay, so we borrow $4,000. The time is 2 years. The interest is what we're looking for. And the future value is really, I'm going to delete this because that doesn't make sense. And the future value is $5,600. That's what we agree to pay the person back. Oh, not 56,000, 5,600. And so that's, wow, that's a 20% interest rate. I'm not sure that that's a friend if they're charging you a 20% interest rate. So if you wanted to be a little clever, I mean, I'm making this video right now. I've already started, so I'm not sure that I really want to. But you could move all this up so it looks kind of cute. So this was your interest rate calculator. This one is your future value calculator, and this is your principal calculator. So you could do some fun things with that if you wanted to. Okay, now it says a bank offers a CD that pays a simple interest rate of 4.5%. How much must you put in the CD now in order to have $1,000 for a home entertainment center in 3 years? So this is really looking for a principal. How much do you need to initially invest? So that's an application of this third this third little program that we wrote. All right, now the time is 3 years, so I'll put a 3 for time. The future value, we want to end up with $1,000. So I'll say 1,000 in here for future value. The simple interest rate is the bank pays is 4.5%. That's in the problem. And I hit enter, and it tells me that I need to put $881.06 away so that in 3 years I will have enough to purchase that home entertainment center. All right. Okay, now wouldn't we like it if everything was simple? But of course, everything's not simple. Sometimes we have compound interest. And what happens with compound interest is the bank calculates your interest, and then it uses your new amount that you have to calculate as your principal to calculate it again. So it's just it's actually compounding. The values compound. So basically, we just have to understand that we have 2 new formulas that we're going to use with our spreadsheet. It says after T years, the balance A in an account with principal P and annual interest rate R in decimal form is given by the following formulas. For n compounding periods per year, A is equal to P times parenthesis 1 plus R divided by n raised to the n times T. And then if you have continuous compounding, it's A equals the principal, and then it's E to the R times T. So this, we're going to learn about how to get this E in the Google spreadsheet also. Now, it says the period of time between 2 interest payments is called the compounding period. When compound interest is paid once per year, the compounding period is 1, and we say that the interest is compounded annually. Most savings institutions have plans in which it's paid more than once. Semi-annually is twice a year, so your N would be 2. Quarterly is 4 times a year, so your N would be 4. So in general, when the compound interest is paid n times per year, we say that there are n compounding periods per year. Okay, and so we need to let me just make some notes here, and I can just type them. All right, so semi-annually is twice a year per year. So that means n is equal to 2. All right. Let's see, quarterly is equal to 4 times per year. So your n is equal to 4. Monthly, I bet you can do that one, is equal to 12 times per year. So that means that n is equal to 12. All right, and then annually, n is equal to 1 because it's just once a year. Let me make this a little bigger for you. Okay, so those are just kind of a little notes for you. All right, so we're going to have to write a new formula. Okay, so I'm going to come down here to I'll go down to A15. Let me move. So those were my simple interest formulas. Now I'm going to write some compound interest formulas. So I'm going to do compound interest. Make my program. Now, what do we need in compound interest? Well, we have A, which is the future value. That's what we end up with. So that'll be the last thing that I'm going to do. You need to input the P, which is your principal. You have a rate, which is your R. You have an N, which is the number of compounding periods. And that depends on the problem. It could be once a year if it's annually, twice a year, 4 times a year, you know, whatever. And then you have T, which is time. And that's always in years. And then we're going to end up with an answer A, which is the future value. Okay, so that's our formula for compound interest. And then we're also going to have a formula for continuously compounding interest. So I'll go ahead and put that one in. Compound. Okay, that formula requires a P, so it requires a principal, P for principal, and it requires a rate, R, and it only requires a T for time. When you look at this formula, that E is actually a command that we're going to get on the calculators, I mean on the spreadsheet, so we don't need to have a row for the E. And of course, we're going to end up with an A, which is our future value. Okay, so we have 2 different formulas that we're going to make little charts for. So maybe I'll do something fun, like I'll make this one maybe kind of a gray color, and I guess I could make this one, or I guess it's sort of a peach color. This one, let's see, having a little fun, maybe pale blue. That's pretty. It's like, okay. All right, and then this compound interest is the general title. So this is just a little thing. What you can do is you can merge these 2 cells. I think that's this button, yeah, and it will, and then if you hit this, you can get it to center. And it looks kind of pretty. And you can do the same thing with these 2 cells. I'm just being fancy here. I can merge them, and then I can center that continuous compounding. So that looks kind of cool, like 2 little formulas. So it's kind of fun. You want to do anything else? I don't know. What can we do? We could put a line. We could put a line at the bottom of that one. And we could put a line at the bottom of this one. Just kind of having some fun, you know, trying to not do math for very long. Okay. All right. So let's work a problem. Here's a long problem. It says, find the accumulated amount of investment of $15,000 for 3 years at an interest rate of 4.5% if the money is compounded semi-annually, quarterly, monthly, and continuously. Okay, so this is really fun because once we write our formula, we can just pop it in and change for A, B, and C. All we're going to do is change the number of compounding periods, and we'll get a new future value each time. So I'll put the principal in as 15,000. The interest rate, they gave us a 4.5%, so 4.5%. Oh, I'm back on the, sorry about that. Okay, the rate right here, 4.5%. Okay, the number of compounding periods for the first one, it's semi-annually, so that's going to be a 2. And the N is, or the time is 3 years, so that's going to be a 3. Okay, now to calculate the future value, let's go back up to our formula and plug it in. It says A equals P times the 1 plus R divided by N raised to the N times T. Okay, so we'll do the equal sign. I'm coming over here into B21. I do the equal sign. Now I take P, which is B17, and I multiply that. So I'm going to do the multiplication sign. Then I have to do parenthesis 1 plus the rate, which is B18, divided by the N, which is the number of compounding periods, which is B19. Then I close that parenthesis. Now, to make an exponent, what you're going to do is you do this we call it a caret or we call it a hat, but it's the symbol that is the shift on the 6. So if you do a shift and then 6, it does that little raise to a power button. Now, it says you need to do N times T, so you're going to put that in parentheses. You do parenthesis. Now, remember, if I try to grab N, it doesn't like to do that for some reason. So I'm going to grab T and then go back and grab N. So I'm going to grab B20, and then I'm going to do times B19, close my parenthesis, and then hit enter. And so it does the calculation for me of when it's semi-annually, the answer is $17,142 and 38 cents. So I could just kind of put in for A here was 17,142.38. Right now, all I have to do for B is change the number of compounding periods. So I just come in here to B and I change that to a 4 and say enter, and notice I get the new value. See, if you compound more often, you end up with a little bit more money. So this is going to be $17,155.12. Now for part C, all I have to do is change the N again. For compounded monthly, I'll change this, the number of compounding periods, to a 12. And then I have a little bit more money, $17,163.72. So 17,000, 163.72. All right. All right. Now part D is different because it's compounded continuously. So I have to come in here and fill out my continuous compounding formula. Now I can put these numbers in. The 15,000 is still the principal. The interest rate is still 4.5%. The time is still 3 years. Now to find the future value, I'm going to come up here to this formula. It's P times E to the R times T. Okay, so pay attention here because this is some new stuff. We're going to say equals the principal, which is D17, times. All right, now to get an exponent in the E in the Google spreadsheet, you type EXP, and it knows that, and it wants to see, it says returns E raised to the power of the given number. So I just do a parenthesis, and then I'm going to do, it's R times T, so it's D18 times D19, and then I close my parenthesis, and then I hit enter. And so it does it. And then I wish that this was rounded just to 2 decimal places. So I'm going to come up to format and then number, and then I'll do come down here and do 2 decimals. Okay, so $17,168.05 is your answer. So just a little bit more money if you compound continuously. So $17,168.05. Okay, so now let's see, we're just going to practice with some more problems. It says, suppose you have $12,000 to invest. Which of the 2 rates would yield a larger amount in 5 years? 8% compounded daily or 7.85% compounded continuously? Okay, well that's easy. Now that we have our formulas, 12,000 is what we're going to put in for the principal. the rate is when it's compounded 8% compounded daily. So we'll do 8%. Darn it. I'm going back and forth between the screens. It's messing me up. All right, hold on. So I'm going to put 8% in for the rate. It's daily, so 365 times a year. And then I forgot what the problem said about for 5 years. So I'm going to put 5 in for the time. So I put a 5 here. And that's how much you would have compounding daily at 8%. Now we'll come in here and compare if we did it continuously. So it's still $12,000. Our rate is a different amount. It's 7.85%. And it's still 5 years. So you have less money. You have $17,768.13 if you have the lower interest rate compounded continuously. So those are the two answers on that one. So so daily, we got 17,901, and continuously we got 17,768.13. Okay, so just two different answers on that one. Okay, so let's go down. And now we have a new formula, a third formula. I think this is the last formula. It's similar to one that we worked on a minute ago. It's asking how much you need to invest to end up with a certain amount. And so this is what we're going to do is calculating present value. So we could come over here and we could say that we're going to make a little present value calculator. And we have, let's see, the principal P. No, the P is what we're going to end up with. So we have A, and then, so I'm going to just copy this one because it's already typed. I'm feeling lazy. So I have my A, I need the R, I need the N, and I need the T. So I'm going to copy these 3 commands. Copy, and then I'll pop those in there. Let's see, paste. And I'm going to end up with the principal. So this is going to be a copy and then a paste. So I'm just doing this to be lazy. Okay. Now I'm going to do this thing where I merge so it looks kind of pretty. So the merging that title, which is the present value calculator. I'm going to underline it because that looks cool. And then I'm going to change the color on this one because I don't want it to be the same because this is a new little calculator. I want that one to be, oh, what color y'all want? Green? That's fun. All right. And then I'm going to take this. This one has a bar on the bottom of it, so I want that off. So I'll come here and do no borders. I think that'll work. Okay. This is kind of dark. Maybe I'll try a lighter green. Here's a little paler green. Yeah, because I like to see the lines. Okay, so that's fun. All right, so there's all the things that I need to make my present value calculator. Remember, I can center this if I want, if I'm feeling like it would be fun to center. Okay, all right, so I've got my little calculator going, and let's read the problem. It says, how much money should be deposited today in an account that earns 6% semi-annually so that it will accumulate to $8,000 in 3 years. All right, so we want to end up with $8,000. That's our A, that's our future value. Our interest rate is 6%. How are they continuing? They are compounding it semi-annually, which is twice a year. So I'll put a 2 in there. And then the time that is, we want to end up in 3 years. We want to end up with this money. So now we have to input our little formula into the P for principal. Okay, so I start with an equal sign. And what you do is you do A, according to the formula, you do A, and then you do divided by, and then you have to do a parenthesis, and then you do 1 plus R, which is B26 times, divided by N, which is B27. Now this is raised to, so remember that's the shift and then the 6 to make a power, and then parenthesis the n, but it doesn't like me to grab the n's, so I'm going to grab the t and then do the n. So I grab B28 and then do times B27, closing my parenthesis, and then hit enter. So you need to deposit $6,699.87. So that's your answer on that one. 699.87. 6,699.87. Okay, so now let's look at the next problem. How much should be deposited in an account that pays 4% compounded monthly so that it will accumulate to $12,000 in 3 years? All right, so you want to end up with $12,000. So that's your future value. It's 4% is the interest rate. Compounded monthly is going to be 12. And 3 years, that just stays the same. So your answer, see, it already calculated for you, is $10,645.17. So I'll do $10,645.17. Okay, let's look at the next problem. All right, it says, you deposit $2,000 in an account that pays 6% interest compounded semi-annually. After 2 years, the interest rate is increased to 6.08% compounded quarterly. What will be the value of the account after 4 years? All right, so this one's kind of a compound interest formula that we have to do twice. So we have $2,000 and it's compounded, it's 6% interest for semi-annually, so that's twice a year, and that's for 2 years. So at the end of 2 years, you have $2,251.02. Now you want to take that amount and figure out how much you'll have if you now have a 6.08% interest rate compounded quarterly. So let's change this to $2,251.02. It's 6.08% now, so we got a little bit better interest rate. And it's compounded quarterly, so that's 4 times a year. And they want to know how much you'll have in the account after 4 years, so this is 2 years at this amount. So then at the end of 4 years, you're going to have $2,539.76. Of 4 years, you have $2,539.76. All right, so that seems like a fun little problem. Okay, let's go on to, I think this is the last question. All right, Dave won a photography contest and received $1,275 in cash prize. Will he earn more interest in 1 year if he invests his winning in a simple interest account that pays 4% or an account that pays 3.75% interest compounded monthly? How much more interest will he earn? In which account will he earn more interest? Okay, so this is fun because we've got 2 formulas. We have our simple interest formula, and then we also have we get to use our compound interest formula. Okay, so let's do the compound one first because it's there. So I've got $1,275, 1 year, 3.75% compounded monthly. So I'm going to come in here. His principal is $1,275. Oops. Sometimes it doesn't. Okay, come on, little thingy. All right, 1,275. His interest rate is, what was it? 3.75%. The number of compounding periods was monthly, so 12. And we want to know how much he has at the end of 1 year. So there it is. Compounded monthly, he has $1,323.64. So now let's do simple interest. All right, to do the simple interest, we'll have to come back up. Our simple interest was this first formula that we did right here. So 1,275, the rate was 4%, the time was 1 year, and and the amount that he would end up with, that doesn't make sense, does it? Oh, I didn't make 4%. Look at me. I need to do 4 and then a percent sign. So if you did the simple interest, it's $1,326 even. 1,326.00. So they're really pretty close, aren't they? But it's actually a better deal for him if he does the simple interest. He earns a little bit more. So to figure out the difference, we could do, you can be snazzy here if you want. Just over like in this cell, you can do an equals and do this number minus this number. That's going to be negative, but whatever. So $2.36 more if he does the simple interest. So simple interest yields $2, 2.36 more. That's kind of the answer to that question. Okay, hope you guys had some fun working or listening and working this homework.